In this video, we're going to be talking about valence electrons. So the valence electrons are outermost electrons in an atom. So they are the ones that are farthest away from the nucleus on average. And the valence electrons are generally the most important electrons in an atom or a molecule, because they're the ones that are really doing the chemistry. So we'll be talking a lot about valence electrons as we go through this course. If you think about what has to happen in order for two things to react, they have to bump into each other. So when two atoms bump into each other, and maybe they're going to bond, maybe they're not, but if they are, the electrons that are going to interact are going to be the ones that are actually on the surface of the atom, the ones that are farthest from the nucleus, and those are the valence electrons. So the valence electrons are responsible for a lot of the chemistry, so we want to be aware in an atom of which electrons are the valence electrons and which ones are not. The rest of the electrons are called core electrons. So the valence electrons are the electrons in the highest energy shell. So for instance, in something like bromine, if we look at the electron configuration for bromine, I'm going to use the abbreviated version. We would have argon, 4s2, 3d10, 4p5. So remember that the big numbers, the coefficients, are the shell number. So if we're looking to identify valence electrons, we're looking for the highest number, the highest shell number. So that would be these electrons in the n equals 4 shell. And we would say that this is the valence shell for the bromine atom. So my valence electrons would be the 4s and the 4p. And we can even write the valence electron configuration would just be 4s2, 4p5. So one of the ways that an atom can react through its valence electrons is to either gain or lose electrons to form an ion. So ions are atoms that have either gained or lost electrons so that they are no longer neutrally charged. So we know in a typical atom, we have equal numbers of protons and neutrons, which means that our charge overall on the atom is 0 or neutral. But if an atom gains or loses an electron, it is no longer neutral, so it becomes an ion. And we have different names for types of ions depending upon whether it gains or loses electrons to become negatively or positively charged. So a cation is a positively charged ion. Note that it is pronounced cation, not Cation. Come back to that. So cations are positively charged, which means that the atom must have lost electrons. If the atom loses electrons, it would now have more protons than electrons, more positive charges than negative charges, which means it would end up positively charged overall. On the opposite side of things, we have anions, which are negatively charged. And these form when the atom gains electrons. If the atom gains an extra electron, it would now have more electrons than protons, more negative charges than positive charges, so it would be negatively charged overall. So to help you remember which one is which, cation, anion, positive, negative, are some little kind of mnemonic memory trick sort of things. So an, ion, the N for negative in there, those go together, can help you remember it. And for cations, I was taught to remember when I was in high school, the cat has paws. The cations are positively charged. So those can kind of hopefully help you remember which one is which. So when ions form, we're gaining or losing electrons. So that means it's going to change the electron configuration of the atom, that the configuration for an ion is not going to be the same as the neutral atom because we have different numbers of electrons. So there's going to be some difference in the arrangement. So when cations form, valence electrons are lost first. So a lot of the time this is going to be exactly what you would expect it to be, and you don't have to think too hard. But if we look at an example like iron, if we write the electron configuration for iron, we will find that it is similar to argon plus 4s2 3d6. So this is for a neutral atom of iron. Has a total of 26 electrons arranged in this way. If we now write the configuration for iron 2+, a positive 2 charge means it's going to have 2 fewer electrons than a neutrally charged atom of iron. So we need to remove 2 electrons from this electron configuration. The automatic habit is to want to remove them from the end, but we need to make sure we're removing valence electrons. So because this 4 is the highest shell number that we have, that 4s2 is my valence shell, is my valence subshell here. So those are the electrons that are going to get removed first. So my electron configuration for the iron ion is going to take away those 2 electrons from the 4s, and that leaves these guys in the 3d6. If you need to remove additional electrons, now you move down to the next shell. So if we wanted to write the configuration for iron 3+, we would now need to remove 1 more electron. Now the 3d5 is the highest available thing. So we would remove, the 3d subshell is the highest thing available. So we remove 1 electron from there to get us down to 3d5. So you always want to make sure that you are removing the valence electrons when you're adding a cation. Anions are easy. When anions form, you just keep adding electrons following the same rules. So if we wanted to do Br minus, the typical configuration for bromine as a neutral atom would be argon 4s2 3d10 4p5, but because of that -1 charge, we're adding one additional electron into that 4p subshell to make it 4p6. So one other thing to note that is interesting about ions is that there's this concept frequently referred to as noble gas stability for ions, that ions tend to be stable or tend to be most stable if they have the same electron configuration as a noble gas. So I mentioned in the previous video that noble gases are particularly stable. They don't really react to anything. So if you create something that has the same electron configuration as a noble gas, it's also going to be pretty stable. And this generally applies to elements in the S and P blocks. Elements in the D and F blocks can have stable ions that are not the same configuration as a noble gas. Also, before I get any further, I need to interject vocabulary word. Something having the same electron configuration is known as being isoelectronic or isoelectric sometimes. Either one is fine by me. But if you say two things are isoelectronic, that means that they have the same electron configuration. So looking at the example that we did up here, this is actually the same electron configuration as krypton. So we would say that Br minus is isoelectronic with krypton. Those two things have the same electron configuration.